Hello guys. So right now I'm going to show you the process of connecting our edge Fortigate Firewall uh, to our internet. So in this scenario I have two internet service provider. Um, this kind of scenario is best for uh, enterprise network design because they can do load balancing. They can also do failover. Let's say ISP1 goes down, our site can still manage to access the ISP2 to be able to have a continuous connection to the internet. So right now I currently don't have configuration here going to ISP1 and 2, so we have to configure that using the uh, Fortigate GUI. So let's start. This is my Fortigate user interface on branch side. We have to go to networks, BGP, and oh sorry, I think I already configured them earlier. Yeah, I already did. So I've placed a local autonomous system 65,001, which is the same with our headquarter, and our local router ID is the same with our loopback interface. So it's best practice to have a loopback interface on each device and use them as their router ID. And then here on my neighbors, so my first neighbor is 198.51.100.10, which is connected to ISP1. Its AS number is 65,002, and the other one is 198.51.100.14, which is connected to ISP2 using the port 9, and ISP2 has an AS number of 65,004. And here we also have to advertise the networks. So this is my network going to ISP2, and this one going to ISP1, which are already configured here. And also later on we have to advertise our local area network on BGP so that they can access our internet. And later on we will also do SD-WAN configuration with the use of route map and prefix list. So we have to, this is very important for enterprise connections, so this route map and prefix list allows us to be able to not make our local area network IP addresses get leaked to our internet. So that's the best strategy for that, and with as well as using the network address translation when going to the internet. So let's start. So our BGP is already done. I'm gonna check the CLI, get router info, BGP network. Okay, now as you can see, I already have a direct connection to 5.5.5, which represents our internet, this one. And also, as you can see, I also advertised earlier the local uh, local interface of branch firewall using the port number 1. As you can see, it is listed here. So it's best to have a prefix list so that ISP1 or ISP2 and the internet won't learn anything from our local area network side. So since I already have an OSPF connection between this firewall and my local area network here, I am now going to configure the SD-WAN. Let me double check first. Now, so I don't need this. This 9.9.9.0 is part of my previous project, which only includes static routes going to the internet. So let me remove that. And 17. Okay, so my management is already also advertised. I'm going to remove this. So now my network is up. So I believe this OSPF connection is a point-to-point connection, if I'm not mistaken. Remove that. Okay, yeah. So this OSPF connection is using point-to-point connection. So let me verify the OSPF connection so that I can see if this branch firewall can access the local area networks. Get router info, routing table OSPF. Yeah, as you can see, I have this. So this is my VLAN local area, VLAN subnets, the 10.4, 10.5, and 10.6, which are VLAN 10, 20, and 40 here. Okay, now we have to advertise that on BGP networks. So I don't have I only want these VLANs to access the internet, not the point-to-point network subnets of this distribution and core. So I have to remove this. As you can see, this is 10.0.0.60, which is used in this link between the core and the firewall. So I'll remove that. Now I'll go and type the 10.4 subnet. 10.5 and 10.6. Okay, and click apply. Now let's try to access the internet through PC9. Let's see if it has IP. Not yet, so we have to iBGP here. Now it doesn't have connection to as you can see, it can find the DHCP server. That means I don't have routes going to my Windows server, which is located here in headquarters. I have one actually. PC9. Oh, okay. As you can see, my Windows server is down, so I won't get any IP address. So I have to turn this up. And let's wait for a few seconds. Okay, let's try iBGP. There you go. Now it got an IP address of 10.4.0.21. Now let's try pinging our internet, which is 5.5.5. Now it says timeout. Let's see if we have firewall policy. That's if firewall is allowing. Okay, now we don't have connection yet. That means our firewall is blocking because we have an implicit deny here, and we don't have okay, let me remove this. Okay, so let's see here if we have our routes to the internet. If we have that, that means it's the firewall policy that's blocking us. We still don't have. As you can see, we still don't have the internet IP here, which is 5.5. Let's verify on core. Okay, now we have, I think we just missed a configuration here on OSPF, because I believe we have to redistribute the its BGP learned uh, routes. So it will inject all of those into our OSPF. Let's try. Redistribute BGP and click apply. Okay, now we have our 5. It is now learned using, since our Fortigate Firewall is using AGP and as well as an IGP of OSPF, so we have to redistribute all those BGP learned routes into our OSPF so that our local area network devices knows how to forward their traffic on to which next hop and destination it will be. Okay, it's still not working because we don't have firewall policy configured yet. So let's verify that by going to distribution, show IP route again. Okay, now we have 5 dot the internet IP here, which is 5.5.5. As you can see earlier, we don't have that in our routing table. So basically, when PC9 is pinging 5.5.5, it goes directly to distribution 1, since this is our active router for HSRP, and it checks its routing table, and it doesn't have the 5.5, so it just gets dropped. So now, before configuring the firewall policy, I want to configure the SD-WAN yet, so that my one facing ports will load balance. So let's go to SD-WAN, create new. We have to create a SD-WAN zone. Let's say BR SD-WAN. As you can see, we can just click OK for now. We have to separately create interface members so I can show them to you how to do it properly. So you can create new again, SD-WAN member, and here I have to include these two link going to ISP1 and ISP2. Let's start with ISP1. Here, SD-WAN zone, we have to choose BR-SD-WAN, and its gateway is the local interface of the ISP1, which is connected to our port number 8 as well. So it's 198.51.100.10 here. Click OK and click create new one. SD-WAN member, the interface now is the port 9. Port 9 is going to ISP2 and the gateway is 198.51.100.14 here. This is the local interface of the ISP2, which is directly connected to our branch firewall. Click OK. Okay, now we have sorry, I think we have to edit this SD-WAN. I forgot to change that into SD-WAN. Okay, there you go. Now we have our SD-WAN zone ready. Let's create an SD-WAN rule. Oh, okay, so before creating an SD-WAN rule, we have to create routing objects, which is the prefix list. So what prefix lists do is um, it actually it only advertise those uh, public facing IP addresses, uh, not the private IP addresses. We can control that using the prefix list and apply them on a route map. So let's say BR okay, so branch out, so create rule here. So I've already pre-configured the rules that we have to configure. I think I've used ChatGPT with that. Let's see. Okay, this is our prefix list that we are going to use. So the first one is we have to deny the we all know that 192.168.0.0, 172.16 and 10 are the only private IP addresses that we can use, and the others are public, right? So now we have to deny all of this from from advertising, from BGP advertising them publicly. So we have to create first the prefix. So the first one is the 10.8. We have to click deny, and this is less than 32. That means that any IP from 10.0.0.0/8 up to that 32 are blocked, so they won't be advertised publicly. They're also the same concept with this other class A and class B and class C IP addresses. Click OK. Okay, we have the first one. Deny again. Click less than 32. So what I mean by that, let's hover here. Let's see ISP2 console, and I will show you the BGP learned network. So show IP BGP. There you go. This is not a good sign. This is ISP2 and it has our private IPs or subnets in there table. This is not a good design, and um, almost all almost all uh, companies do this. So don't allow this. I mean, so this is not allowed for your company security for sure, so that the they don't have any access to your private networks. Now let's create another one. Okay, specific and less than 32. And as you can see here, we are permitting this network. So this is what we are currently using now. This is our one facing subnets, 198.51.100.0 deny. And lastly, we are permitting this one facing subnets to be learned by other peers. Okay. Click OK. Now create new and click route map. Route map out. Okay, so let's create a rule here. So we are permitting the matching IP addresses which we configured on our prefix list. So match IP address and click the BR out. So this BR out is only permitting this one interfaces, one subnets, and will be denying this class A to C private addresses. Okay. And now click O. Yeah. And click OK. Now head on to BGP and this and now this is our BGP neighbors. Go to BGP, click the neighbors, and we have to route map out here. That means we are only allowing the 198.51.100.0 subnet to be learned by other autonomous system, which is the ISP1 and ISP2. And click the RM route map. Okay. Then click OK. Also with this other one, route map out. Okay. Click OK. And click apply. Now let's see if we still have our private networks in our ISP. Okay, so we have to wait for them to sync. I believe I did everything right. It still has the 4, 5, and 6. I believe I miss something here. Okay, so we have to create SD-WAN rules. Okay, BR SD-WAN. Our source address is our local area network. Let me see. Let me check first on my headquarter. Okay, this is also not good. So LAN 10.1, right? So what I'm doing is, this is our SD-WAN rules, which will be, this is where you configure it on how you forward traffic to the internet. So this is my headquarter. I've got the source address wrong, so we have to add our local area subnets. That since our subnet here are VLAN 10 to 40, we have to include all of them so that they can access the internet as well. Okay. Okay, now on branch firewall source address, I'll create a new address group. So this is LAN, let's say LAN 1, and I'm gonna add, since I've already configured an IPsec tunnel here, I can just go and use this local subnets. Okay, so I'm only allowing VLAN 10, 20, and 40. And close, click that LAN 1. Now we have our source address here. I'm going to choose the maximize bandwidth. It says traffic is load balanced among interfaces that meets SLA targets. Okay, so our interface preference is port 8 and port 9. And our zone, BRU SD-WAN zone, and required SLA target. So we have to this is like the destination of the of our internet address. SLA net. Our server is 5.5.5.5. Our protocol is ping. Click on the SLA target. Let's give this latency threshold of 20. So the link status will be checked every 0.5 seconds. And click OK. Okay, now we have to choose this SLA.net. And status is enabled. Destination is all. And protocol is any. Okay. Click OK. There you go. Now we have our SD-WAN role. Let's go to our static routes, and we can just remove these two static routes configured earlier. This is basically going to ISP1 and ISP2. Now we have to create a new one, and our interface here is the BRSD1. And click OK. Now go to firewall policy. Since we already finished creating SD-WAN, as you can see, it is now load balancing. Okay. And 0 packet lost. Now we have to create our firewall policy. This will allow the local area network to access the internet. Create new. BR, let's say LAN 2 internet. Outgoing interface is BRSD1. We can choose our source address LAN 1 and destination all, services all, and accept, and they're doing network address translation. So now everything is good. Let's check first our ISPs if they can still see our private networks on branch and headquarter. Let's go to their console. ISP1 show iBGP. Okay, now all they can see is our one facing interfaces, which are public IP addresses. On ISP2 show iBGP. There you go. Now let's try accessing let's try if our end devices can now access the internet. As you can see that our SD-WAN is now load balancing. It's using both ISP1 and ISP2. So let's ping 5.5.5.5 and let's ping it 50 times. Okay, now it's working. Now let's try to shut down the ISP1 interface, disable the ISP1. As you can see, the ping still continues because we still have our ISP2 running on our SD-WAN. As you can see, ISP1 is down, but ISP2 is taking over to continue the packet. Okay, thank you. That's everything.